An unfair die looks like an ordinary six-sided die, but the outcomes are not equally likely. The probability distribution of the face value is as follows. I think this is a bad die because 0 shouldn't be a possibility on a die, right? Yeah, anyway, we'll just skip over that part. So we're looking at the probabilities of outcomes for the die. And it appears that not all of the probabilities are equally likely. And that's what would happen in a weighted die that's not a fair die. Let's just use the distribution as is to answer the questions. What's the probability that the value of the random variable x is between 4 and 5? So this notation right here means between, but the word between is not precise. It doesn't tell you if it includes the endpoint or it does not include the endpoint. So this notation is a little bit more precise, and you can see things like if it's less than or equal to, then it includes the endpoint. If it's just strictly a less than, then it excludes that endpoint. So it's a little bit easier to identify exactly which probability you're asking for. So the probability that x is bigger than or equal to 4, okay, so starting with 4, but then it has to be less than 5. So less than 5. Well, this is apparently just a very fancy way of asking what is the probability that x is equal to 4. Because if it's greater than or equal to 4 but less than 5, that's the only outcome that qualifies. So our probability there is 0.19. Perhaps the next one will be a little bit more illustrative of how to do these. The probability that x is between 1 and 4 exclusive. So the way we read this is we look up first the probability that x is greater than 1. So we don't start with 1, we start with 2. That's greater than 1. But then it also has to be less than 4. So if it's less than 4, then it could be 3, but it could not include the 4. So these are the only two outcomes that qualify of numbers that are between 1 and 4, but not including the 1 or the 4. So the probabilities that we add together are the associated probabilities here. So our answer will be 0.19 plus 0.3, which is 0.49. The probability that x is less than 6. If x is less than 6, let me erase my marks up here, then it can be any value up to 6, but not including 6. So 0, 1, 2, 3, 4, and 5. All of those numbers are in our sample space and are less than 6. Which means we need to add all of these probabilities together to get our answer. Now, we could absolutely do that, but one thing that we know is that the sum of all probabilities is equal to 1. And so if we don't want to take the time to add these together that are highlighted, what we could do is say, well, the sum of all of these, the highlighted and the non-highlighted, is equal to 1. So the highlighted ones would be 1 minus the non-highlighted ones. They would be complementary to each other. So that would tell me the answer is 0.96. Let's just try it out, adding those together, and see if it works. So if I take 0.05 plus 0.12 plus 0.19 plus 0.3 plus 0.19 plus 0.11, they indeed add up to 0.96. So it works out because all the probabilities have to add to 1.